Alright guys, we are back, and today we're going to get into a little bit more about what our roadmap is actually going to look like. As of now, we've just been setting up our environment. You should have your ClickUp space. We should have a version control with GitHub. And now we're ready to start moving towards real design. But before we do that, I go over here in our design decisions doc, and we're going to outline a little roadmap as a subpage, because we need to know where we're going and what the big ticket items are along the way. So first things first, we kind of want to define a goal. And the goal of this project, which none of you probably know yet, but I've had in my mind for a bit, is to design and spin up, which is another name for manufacture, in this world of PCB design. If they say spin up a board, they just mean get it made. Every industry's got to have their special terminology to make them feel cool. But we're going to design and spin up a printed circuit board, PCB, that, let's see here, using GLC PCB assembly. GLC PCB is the company. They will spin up boards and you can solder components to them. They also have a service called assembly, which will spin up the board and attach and solder the stuff on for you. I think for early learning and getting some early success in your designs, this is a good route to go. And if we do it right, we can make it pretty reasonably cheap. So we're going to design and spin up a printed circuit board using GLC PCB assembly. And grammatically, I'm trying to think how to say this. I know what I want to say. In our KiCad design software. And so you may ask, why are we using KiCad? Well, KiCad is an open source, free PCB design software. And essentially what that means, what it means is we don't have to pay for it. Open source, the idea behind open source is you have the community making programmatic contributions. It's not just the big corporation or whoever's running the software itself making contributions. KiCad gets us to where we want to go, I would say. And that's the case with a lot of open source tools, I think, is if you need A, free, B, get pretty close to what you need, as long as you're not doing, fringe physics, which even some fringe, we use OpenRocket, that's an open source software. And obviously that does a pretty good job of sometimes better than RockSim, I think, of getting to our altitudes or getting our rockets simulated. So there's some benefits to it. It's a way of software thought, but we use it because we don't want to pay for Altium and Eagle are the two I know. I'm sure there's others, but they're very expensive. And they can do a lot of awesome things, there's no doubt, but they're, again, quite expensive. So for the purposes of what we're doing here, KiCad's going to get us where we need to go. And that's kind of the case with a lot of software, especially in engineering. There's open source versions of MATLAB, which get you most of the way there. And if you find out that you need the real MATLAB because you're doing something that only MATLAB can do, then you can go get MATLAB. Until then, you can get there. Obviously, Python is known as the secondary one, but I think there's a couple other ones out there. So you can get what you need for free as long as you're willing to learn some janky. Sometimes the software is a little janky and hard to learn because you don't have professional UI developers working on it, but if you learn it, it's still very powerful. So we're going to use KiCad, which means you'll want to download it. I trust you guys can figure that out. The only thing I'd say is try to download KiCad 9, because that's what I'll be using. So for those of you who have KiCad, you may need to update it I'm pretty sure KiCad is sleek enough that if you just download KiCad 9, it'll overwrite your KiCad 7 or 8, whatever you're on. If you are going to use an older KiCad, which is fine, if you ask me to review something, please let me know you're using an older one so that I can also use the older one when I review it. Because if I open it in my KiCad 9, I am going to possibly screw it up where you won't be able to open yours with your older software after the fact. Because I'm pretty sure it steps it. It might step it up. It might not, but just let me know so that I know what I'm dealing with, and I can just be in the same development environment as you. And for you following along, KiCad 9 will be right. So we could probably even put that in our goal there, KiCad 9. That's our goal. Now, this is a roadmap, so we got to talk about how we're going to get there. Well, first thing we need to do is we need to define board requirements. We're going to hopefully get into a little bit of that today. The reason I'm doing all this in this nice ClickUp document is I can make a task just by doing that. Assign it to me. And there we go. It's in the backlog. Go check the list here. Define board requirements is in there, and I went. My status, we take a look. My board requirements is sitting in my backlog, which is great. After we define our board requirements, we're going to need to do a first construct first bill of materials, otherwise known as the BOM. You may ask, why are we going to do that of the requirements? Well, A, we need to know what we're going to make KiCad, and so we need to know what parts we're in theory using, at least the main ones. Secondly, we can't just, you could design with general boards, say, I'm going to do a sensor that has this footprint and it's, I can wire it up with these things. You could do that. I wouldn't recommend doing it. I don't know if anyone does it. But you can do it, especially with some boards. And the drawback to that, if we're using this assembly, is we don't know if JLC PCB has the part. We need them to have the part in order for us to have them manufacture it. So we're going to look through JLC PCB to say, okay, what do you have? What are we going to build? I'm going to benefit from having built before to kind of know what needs to go on that first bill of materials, but I won't know everything, and I'm sure we'll add more as time goes on. So once you build the bill of materials, we're going to want to design KiCad schematic. Now the word schematic there has an important word. You can kind of guess what schematic is. If you take an electronics with Beacon, it's what's in your lab manuals. It's the diagrams. And we'll make our own diagram for the board we're making. And if we look at KiCad here real quick, KiCad, for those of you who haven't used it, it kind of has two main interfaces. The first one is the schematic editor. Sometimes you see it referenced as Ischema, I think. But the schematic editor, and then you have the PCB editor. What's the difference between these two? Schematic editor is you wiring it. And KiCad actually even lets you do some circuit simulation if you really want to. But there's better tools in KiCad for it. But it's maturing over time, so maybe eventually it'll be worth it. But that's for a lot of analog type stuff. And then the PCB editor is your CAD. And that's where you'll be physically outlaying how the board will actually look. So when we say schematics, we're very specifically talking about this application, this environment. And when we say PCB editor, we're talking about this environment. We have to design the KiCad schematic. Then we're going to do a step that I call JLC PCB validation. I've been burned a couple times by not doing this. And so what this essentially is after we design everything, we go ahead and we try to validate our projects so that in the end, when we need to export everything to hand it off to JLC PCB, we have everything we need in clicks, and we don't have to try to track down or remember what component we use for these different things, yada, yada, yada. So we're going to do a validation step. It'll be another chance to look at the bill of materials to make sure that's right. We're going to make sure we have all the part numbers attached to the symbols and make sure they're all formatted so we can just export a bill of materials really easy, straight out of KiCad. Don't have to mess around with anything. So we'll be taking that step. Part of the other reason I want to enforce this step is in a team. A lot of times how it's going to work out is you're going to have KiCad schematic electrical engineers. Yes, not KiCad, but you'll have an electrical engineer that actually does the schematics, and they'll make up the blueprint essentially. And then you'll have a separate person that does the actual CAD. They'll be called, designers, PCB designers. They won't have the engineer tag often. And so this is a really good thing for you to do if you're in the position of an electrical engineer that's not doing the CAD, to make sure that everything is right and you're not going to be making non-scope changes. And by scope changes, I mean, we're going to define the requirements. If we make a change to those requirements in there, after we send the schematic off to the PCB editors, who's going to be you in this case, but in the future might not be. The only thing that's going to make us make a huge fundamental change to that stuff is if we add something to those requirements later on, which can happen in project, and you got to learn how to kind of take the punches and roll. But we would like to avoid that, and we definitely don't want to have one of our requirements unless GLC PCB pulls something off the shelf last second and we don't have it. Those things can happen, but we don't want to be making preference changes after we send this off to get CAD done, because that can really screw up their workflow. We're going to validate the project. It's just a good step. It's good QC. By QC, I mean quality control. So after you validate, we'll do a PCB editor CAD. Some of you might find this really enjoyable, more than the schematic editing. It can be a little more relaxing when you get good at it, because it's more of it's a designer role. It's not a thinking engineering role. You have to know how to engineer things up to be good at it, but you don't necessarily need to come up with novel solutions and architect how the whole thing's going to go together. You can kind of just wire it. You can look at it and you can say, that looks nice, and that's usually a good determiner on whether it's right. So we'll be doing the CAD. After we do that, we're going to export fabrication files for JLC PCB. This will be nice. Good step. All done in KiCad. They make it pretty easy to kind of click a couple things and you can get everything you need. JLC PCB's got articles to tell us what they need, and I appreciate what KiCad has done to make that process really easy. And after we do that, we'll ship it off to JLC PCB. Send to for fabrication. Since I've been doing that all the way around. And then you'll have a board on your way. I'm going to give because the end goal of this project is to send it to an external company, make the board, there's going to be a reality, which is that there's going to be a cost at the end of this that you'll have to decide whether or not you want to make it. I've always bought my own boards that I've made, even if they're for the club. If you can convince people within the club to cover your costs, that's up to you and the club. I wouldn't expect it, just because it's outside the scope of what the club necessarily does right now. But especially if it's not one that's going to go on a rocket, and there's a bit of, if the club pays for it, the club keeps it. You don't get to bring it with you after you're done. And I think some of you will want to keep it. So I'd encourage you to pull out the budget to pay for this. Now, the good news is the board we're designing, we're not going to go crazy on expense, and a lot of times they're not super expensive in small batches. So what are we going to, this is a very rough estimate, rough order of magnitude estimate. I would say the board itself would be looking anywhere from the $25, bump that up to the $50 range. And what that's going to get us is going to get you 2 fully fabricated printed circuit boards and 3 non-assembled ones without components. So that's going to be 2 fully assembled boards from JLC PCB and 3 non-assembled ones. If you want to spend a little bit more money, you can get 5 fully assembled ones if you want to do that. But all in all, it's not going to be hyper expensive. You know, this is kind of what you expect to spend on any side electronics project. Sometimes you can climb into even more, especially your first one. You know, electronics, we like buying in bulk, and when you buy in bulk, the first project's really expensive and the next projects are super cheap. So it's just kind of balancing all those things. But in this case, that's kind of what you're looking at the end. So I didn't want to necessarily sticker shock anybody. Even if you're like, I'm not going to pay for that in the end, I would still go through this because it's a worthwhile skill to learn. So this is our roadmap. This is where we're going. Still might not mean a lot to a lot of you. Some of you maybe get it. Some of you are like, I don't think this is really going to work. Or not really going to work, but you may be thinking there's way too much going on here and I don't want to do it. Or you'll be thinking, hurry this along. Whichever which way. I'll speak to those that maybe look at this roadmap and say, oh, I can't do all that, or I'm not going to do all that, or I'm getting so lost I don't even want to do this anymore. That is going to be the first board. Once you get past your first board, the second one gets easier, and the next one gets easier. And at some point, you kind of get into this trajectory where hard, or it starts hard, and then it kind of gets easier, and then you hit this point where you say, ooh, I could actually design things. It gets really hard, but it gets enjoyable because you're doing a cool thing. And you kind of get to, you know, I mean, there's something about fabricating something yourself and seeing it happen. So, this is the roadmap. Now, some of you maybe don't have a real picture in your head of what a printed circuit board is. I wouldn't have if I was sitting in your position right now. So why don't we take a look? So you know what we're building up towards. So, a printed circuit board, I like to explain it as take a normal circuit with your wires and your breadboards, and you squish it all down into a 2D surface, and you get all your connections, and everything's really small and much more reliable. So, it's a copper plate. And we etch what we call traces, which are just wires essentially, into that copper plate, and then we insulate around those traces to get your circuit. And that's really all it is. It's not super sophisticated, but this is what lets you get from, you know, if you've seen like a Raspberry Pi or a Pico, maybe they have one in here. It's kind of, you know, this is like a big printed circuit board, which is all the Raspberry Pis and Arduinos are. There's one. You see, it's just a printed circuit board. But they're big, they're bulky. And I always used to, when I saw these for the first time, I thought to myself, you know, man, that won't fit inside an Apple Watch, right? You look at that, and you're like, that's way too big. How do people make things like an Apple Watch? And that's kind of how I stumbled across the reality that you could make your own printed circuit board, because I started figuring out, like, oh, I don't need 80% of what's on here to make a lot of stuff. It's a great general board to do generally anything, but you got a lot of wasted space, you got a lot of wasted power. So if you can get to the level where you can build your own printed circuit board, now you can have your own computer chip that does exactly what you want. It has limited wasted space and money. So this is a printed circuit board. It's just a much more efficient way to do wiring of a circuit. So that's what we're going to be building. Let me check the time on this one. It's I think we can push this one a little bit longer. Decide if I want to cut it off there. Actually, let's cut this off here. I'm going to record another one that does after this. We'll kind of get into price setting up, how we want to timeline this sucker. And then we can start getting into defining the board requirements. But this is the roadmap. So hopefully you have a better idea of where we're going, what we're doing. And I hope you're getting excited. Not keep hanging on with me. It will get exciting at some point for you. So thanks for watching and listening, guys, and I will see you next time.